Baby born after being frozen as an embryo for 24 years. 24 years is a long time to be on ice. Just ask Emma. Emma Wren Gibson was born on November 25th from an embryo that was cryogenically frozen 24 years ago. The embryo was created for in vitro fertilization by an anonymous couple and placed in cryogenic storage on October 14, 1992. Emma's parents, Tina and Benjamin Gibson, chose embryo adoption after realizing they were unable to have children. The Gibsons selected Emma after reviewing around 300 donor profiles listing basic genetic information about the biological parents. Talk about being a cool baby. Keep watching for more medical stories.
Gray hair and baldness may soon be a thing of the past. Scientists researching tumors may have accidentally found the cure for gray hair and baldness. Two proteins, KROX20 and stem cell factor, are responsible for hair loss and pigmentation in hair, respectively. Hair shafts turn white when stem cell factor is depleted from hair cells. Meanwhile, hair loss is observed when KROX20 is removed from hair cells. Researchers will continue to study whether the two proteins stop working as people get older, which also could help explain why people age in general.
Malaria vaccine could lead to general cure for cancer. Scientists researching a vaccine against malaria in pregnant women may have accidentally discovered an effective weapon against cancer. Scientists from the University of Copenhagen and the University of British Columbia have identified that the carbohydrate the malaria parasite attaches itself to in the placenta of a pregnant woman is identical to a carbohydrate present in cancer cells. Scientists have created the protein that the malaria parasite uses to attach to the placenta in a laboratory and have added a toxin. The combination of the malaria protein and toxin finds cancer cells, is absorbed, then the toxin is released inside, causing the cancer cells to die. Research groups from the two universities have tested thousands of samples, from brain tumors to leukemias, and have found that the malaria protein is able to attack more than 90% of all types of tumors. The drug was tested on mice implanted with 3 types of human tumors: non-Hodgkin's lymphoma, prostate cancer, and metastatic bone cancer. The mice that were given doses of protein and toxin showed far higher survival rates than the untreated mice. Researchers are now working towards being able to conduct human trials. They say the earliest possible time frame would be in 4 years.
Hawaiian woman becomes first in Asia-Pacific to receive bionic eye implant. A 72-year-old woman in Hawaii who was blinded by a hereditary eye disease 2 years ago received a bionic eye implant last week that will partially restore her vision. In a functioning eye, rod cells and cone cells located at the back of the retina convert images to electrical impulses that are then sent to the brain. The Hawaiian woman, who recently underwent the retinal implant procedure, was blinded by retinitis pigmentosa, a disease that causes the retinal cells to degenerate. During the implant surgery, the eyeball is attached to a bionic case with an electronic array that's implanted underneath the retina. A camera attached to the bionic glasses captures images. A video processing chip then converts these images to electronic pulses. The signals are sent back to the glasses, and the pulses relayed to a receiver on the eyeball. The receiver transmits the pulses to the electronic array, which then uses these pulses to stimulate the optic nerve and send the information to the brain. The bionic eye implant is currently only able to restore partial vision. After the implant, the woman will be able to detect motion, and eventually she'll be able to see up to 9 colors.
Ultrasound shows promise as non-invasive treatment for Alzheimer's. Australian researchers have found that mice suffering from Alzheimer's perform much better in behaviour tests after receiving ultrasound treatment, a discovery that could give hope in the battle to find a cure for humans suffering from the degenerative illness. Neurotransmitter activities are disrupted in the brain of Alzheimer's patients. Beta amyloids, a natural protein, accumulate in patients' brains, leading to the formation of plaques that can damage nerve cells. The cerebral cortex of Alzheimer's patients also shrink as symptoms progress. Scientists at the University of Queensland in Australia conducted a series of tests in which they injected a solution containing tiny gas bubbles into mice. Ultrasound helps the gas bubbles expand, The bubbles then temporarily open a gap in the blood-brain barrier, allowing the entrance of antibodies into the brain. The antibodies remove toxic beta amyloids and thus reduce the size of the plaques in the patient's brain. Researchers now plan to carry out the same tests in larger animals such as sheep. Tests in humans will be more difficult because the human skull is harder, meaning ultrasound waves cannot easily penetrate it.